Okay students, now let's do the next problem in node analysis. Okay, here the question is find the voltage across the 5 ohm resistor of the given network. Alright, so here this is the circuit they have given. Alright, so here for this video I just want you all to just pause this video and try to do this problem by yourself without my help. Okay, and then after that I want you to just compare the answer and see if your method is correct. That's the best way to learn. Alright, so here in this question you see they have not mentioned which analysis you need to do. Should you apply node analysis or should you apply mesh analysis, right? Of course our chapter is node analysis, but suppose in the exam they may not ask you which method to use. They will not ask you whether you should apply mesh analysis or node analysis. In that case, how do you know which method is easiest? For that, you just have to take a good look at the circuit and tell which is more in number. Is it the meshes or is it the nodes? For example, if you look at the mesh in the circuit, how many meshes are there in the circuit? 1, 2, 3, 4, which means there are 4 meshes in the circuit. 4 meshes means that there will be 4 mesh currents equation, I1, I2, I3 and I4, right? But if you apply node analysis, you can see that this circuit has only 3 nodes. And what are those 3 nodes? I will mark it in different colors. That is, this is V1, this is V1 and this is V2 and this is V3. You see the 3 nodes, this equation. There are only 3 unknown nodes because the rest of the nodes are the values you all know the value. The voltage at this node is 12, the voltage at this node is 0, the voltage at this node is 0, the voltage at this node is 0, the voltage at this node is V1 itself, because see V1 is connected to all these shots, right? So therefore the voltage at this node is V1, the voltage at this node is V1, the voltage at this node is V2, the voltage at this node is V3, the voltage at this node is also V3, the voltage at this node is also V3. See, because these are all short to one junction. So this is all one voltage. This is also one voltage. See, so this is how we can tell that node analysis is better, because the number of nodes is lesser than the number of meshes. So it's good to apply node analysis. Okay, that is how you should understand which method to apply, right? So now I'm going to apply node analysis, so which means now I'll be writing the node equations of V1, V2 and V3, right? And look what the question is. Find the voltage across the 5 ohm resistor. What is the voltage across the 5 ohm resistor? The voltage at one end of the resistor is V2 and the voltage at the other end of the resistor is V3, which means the voltage across the resistor or the potential difference across the resistor is V2 minus V3 or V3 minus V2, whichever answer is positive, right? If V2 minus V3 is negative, which means that V3 is higher potential, therefore the current is flowing from V3 to V2. That's the only difference. If likewise, if V2 minus V3 is positive, which means V2 is higher potential, which means the current is flowing from left to right. Okay, so that's the thing. So what you need to find the value. So this question actually means you should find the value of V2 and V3 only, and then take the difference between these two. That's the question. Alright, so let's write the equation. So first I will start with the equation of V1. Okay, so equation of node V1, equation of node V1. Okay, I'll use a green pen. Equation for node V1, right? So what is the equation for node V1? You see how many branches are there this V1 has. Look very carefully how many branches this V1 has. See, this is one branch, right? So that means we are going to assume there is an outgoing current like this. Then this is also another branch, which means there is another outgoing current like this. And then here also there are 2 more branches, right? This is another branch and this is also another branch, which means totally there are 4 branches connected to V1, right? 4 branches, 1, 2, 3, 4. 4 branches, which means there will be 4 terms in this equation, right? So let's write each and every term. So what is the term for this current? The current is flowing from V1 downwards. What is the name of that current? It is V1 minus 12 by 4, right? V1 minus 12 by 4 is the current flowing downwards. Now what is the current flowing in this direction? See, because V1 is always considered as a higher potential, since you are assuming all the current as outgoing current, right? It's flowing from the junction. So therefore V1 is always having, in whatever terms you're writing over here, V1 will be having the higher potential. So here the current is flowing from V1 to V2 and it's going through the 2 ohm resistor, which means the current through this branch is V1 minus V2 by 2. Correct? Now next is the current flowing in this branch, right? The current flowing in this branch. In that case, what is the node voltage? That is V1, right? V1 minus V3, right? The voltage at this end is V3. Here the voltage is V1, here the voltage is V3. So therefore V1 minus V3 by 4. V1 minus V3 by 4, right? Plus, correct? Plus, now what about the current over here? See, you can see here you don't need to write the voltage across it. You don't have to write, because here the current is already shown over here. They have already told you what current is flowing through here. What is the name of that current? That current is 9 amperes. Okay, is it plus 9 or is it minus 9? It is plus 9. The reason is because this 9 ampere current is flowing outwards, right? This is going the same direction, flowing outwards. You see, because like I told you, when you are applying the Kirchhoff's current law, all outgoing currents are considered positive and all incoming currents are considered negative. So this 9 ampere is positive. So it is plus 9 equal to 0. This is Kirchhoff's current law. Okay. So now what I'm going to do is I'm going to express this equation in terms of V1, V2 and V3. So which means V1 will be positive, right? So let me see, it will be V1 into 1 by 4 plus, here this 1 by 2, 1 by 2 plus, here this again 1 by 4, 1 by 4. Okay, 1 by 4, right? Minus, so that's V1 is over, next is V2. V2 is only over here, right? So it is minus V2 into 1 by 2. Okay, and V3 is only over here, so it will be minus V3 into 1 by 4. Okay, is equal to the remaining constants I will be taking outside. What are the remaining constants? There's one constant over here, right? Minus 12 by 4. What is minus 12 by 4? Minus 12 by 4 is minus 3, which means this will become plus 3. So it will become 3. And then it will be one is over here 9. So this will become plus 9. So it will become minus 9. So 3 minus 9. This is the equation. Okay. So let me find what is this. What is the coefficient of V1? This 1 by 4 plus 1 by 2 plus 1 by 4. Let me see. 4 inverse plus 2 inverse plus 4 inverse, and you will get 1. So which means V1's coefficient is 1 itself. So we say, write V1 over here, V1, alright, and here 1 by 2, right? 1 by 2 is nothing but 0.5, right? So you don't have to put that in the calculator. So V2 into minus V2 into 0.5, okay, and 1 by 4 is 0.25, right? So it is minus V3 into 0.25 is equal to, and 3 minus 9 is minus 6. This is equation 1. Okay, this is equation 1. This is how we write the equation of node V1. Right. Next I'm going to write the equation for node V2. Okay, so equation for node V2. Okay, so V2. So if now you're going to look at V2, right? So how many branches does V2 have? V2, see, this is one branch is going outward direction like this. The other branch, it is going outward direction like this, and the other direction is like this, right? So this is V2 direction, right? So there are 3 branches, right? This one, this branch, and this branch, right? So I am going to assume all the currents are outgoing currents, so that everything will be starting with V2 minus, V2 minus, V2 minus, like that. So I will start with, so first I'll write the current across this branch. So in this branch, the current is flowing from V2 to V1 across the 2 ohm. So what is the name of that current? The name of the current is V2 minus V1 by 2. Okay, that is the current through this branch. And what is the current through this branch? Plus, it's outgoing, right? That's why it's plus. That's why it's always plus, because all the currents are assumed to be outgoing. So what about this current? This is V2 minus 0 by 100. V2 minus 0, the voltage at this point is 0. So V2 minus 0 by 100, or V2 by 100. Okay, plus, and what about this one? The current through this branch going from left to right, it is V2 minus V3 by 5. right? Because V2 is a higher potential, right? So V2 minus V3 by 5. So V2 minus V3 by 5 is equal to 0. This is the equation of V2. Okay, now I'm going to write it in terms of V1, V2 and V3. So this will become, let me see, this will now become minus V1 into, and V1 is already only over here, right? So it's 1 by 2 minus V1 into 1 by 2 plus, and V2 is having 3 terms, right? 1 by 2, 1 by 2 plus 1 by 100 plus 1 by 100 plus 1 by 5 plus 1 by 5. Okay, minus V3 into, here it is 1 by 5, 1 by 5. Okay, are there any constants over here? No, no constants, right? There's no other value, only V2, V1, V3. So this is equal to 0. That's it. Okay, so that means this equation is, this is minus V1 into, we know 1 by 2 is 0.5, right? 0.5 plus V2 into, let me see what is the value of this. That is, this is what, 1 by 2 plus 1 by 100 plus 1 by 5. That is 2 inverse plus 100 inverse plus 5 inverse, and we have is 71 by 100 or 0.71. So this is V2 into 0.71 minus V3 into 1 by 5 is nothing but 0.2, right? 0.2 is equal to 0. This is equation 2, right? This is equation 2. So we have equation 1 and now we have equation 2. Next I will be writing the equation for V3, right? Equation for node V3. Let's write that. That is equation for node V3, right? V3. So what is the color of that? Orange, right? Orange. So we'll use orange pen. So V3 means how many branches are there? Let me see how many branches. This is 1, okay, 2, right, and 3, but there are 4 branches over here. So this is 3 and 4, which means there are 4 branches, right? There are 4 branches. So let's write the equation for each of these 4 branches. First I'll write the current through this branch, right? What is the name of the current through this branch? V3 minus 0 by 20 or V3 by 20, right? V3 by 20 is the current through this branch. So it's just V3 by 20 plus, next, what is the current through this branch? The current through this branch across the 5 ohm, it is flowing from V3 to V2, it is flowing from V3 to V2 across this 5 ohm resistor, which means the current through this branch is V3 minus V2 by 5 plus V3 minus V2 by 5 plus, now what is the current through this branch? It is flowing, the voltage over here is V3 and the voltage over here is V1. So it is V3 minus V1 by 4. This V3 minus V1 by 4. Okay. And then last is over here. In this current, it's not resistor. This is the current source, right? Which means the current is already mentioned. What current is mentioned is already shown over here. So what is the name of the current? 9 amperes. Is it plus 9 or minus 9? It is minus 9. Reason is because this current is incoming. It's not outgoing, it is incoming. Or in other words, this is your assumed current, right? This is the current that you have assumed. The current assumption is in this direction, but the actual current is flowing in the opposite direction, which means this is minus 9 ampere. Or in other words, this 9 ampere is incoming. It is going into the voltage V3, right? It is going into the node V3. It is incoming current. So all incoming currents are considered as negative. That's why this is minus 9. So this is minus 9 is equal to 0. This is the equation. Okay. So now I am going to express in terms of V1, V2 and V3. So therefore this will become, first I'll start minus V1 into, V1 is already over here, right? This is 1 by 4. Okay. Then next it will be minus V2 into, and that's only over here I believe, that is 1 by 5, 1 by 5, and then it will be plus V3 into, it will be 1 by 20, right? 1 by 20 plus 1 by 5 plus 1 by 4 plus 1 by 5 plus 1 by 4 is equal to 9. There's no other constants, right? So it's minus 9 become plus 9, right? So what is 1 by 4? 1 by 4 is 0.25, right? So it is minus V1 into 0.25 minus V2 into 1 by 5 is 0.2. So 0.2 plus V3 into, let me see, 1 by 20 plus 1 by 5 plus 1 by 4. What do you get? 20 inverse plus 5 inverse plus 4 inverse, and you will get is 0.5. So this is plus V3 into 0.5 is equal to 9. This is equation 3, right? So expressing now equations 1, 2, and 3 in matrix form. In matrix form, we get, so let me see, what do we get? So which means the coefficient, what are the coefficient matrix? Let's write that carefully. What is the, here, what is the coefficient of V1? The coefficient of V1 is 1. Here it is minus 0.5 and minus 0.25. Minus 0.5 and minus 0.5 and minus 0.25. 0.25. Okay. Now what about the second equation? The coefficient of V1 is minus 0.5. Then the coefficient of V2 is 0.71 and the coefficient of V3 is minus 0.2. So it means minus 0.5, minus 0.5, 0.71 and minus 0.2. Minus 0.2. This is the coefficient of V3. Next is the coefficient. Next is the third equation. The coefficient of V1 is minus 0.25, right? So minus 0.25. The coefficient of V2 is minus 0.2. Minus 0.2. The coefficient of V3 is 0.5. So it is 0.5. Okay. V1, V2, V3 is equal to. Now what about the constants? The first constant is minus 6. And the other one is 0 and the other one is 9. So it is minus 6, 0, 9, right? This is the matrix form. So the question is to find V2 and V3. So I'll find only V2 and V3 from here. Okay, that's more than enough. So I'll find V2 and V3. So what is the equation for V2? V2 is equal to the determinant of, that means here the second column will be replaced by the constants. So it will be 1 minus 0.5, 0.25, minus 0.25, and here it will become minus 6, 0, 9, and here it will become minus 0.25, minus 0.2, 0.5. This is the numerator by, and the denominator will be the coefficient matrix, which is 1 minus 0.5 minus 0.25 minus 0.5, 0.71 minus 0.2 minus 0.25 minus 0.2 and 0.5. Okay, so now I'm going to find the value. So let's start. So this is 1 into, so 1 into, this is 0 and this is 1 is 0, minus of minus is plus, so this will become 1.8, right? 9 into 0.2 is 1.8, so this is 1.8. Okay, minus of minus becomes plus, so this is becomes plus 6 into, okay, 6 into, let me see, this is minus 0.5 into 0.5 is minus 0.25, right? 0.25, and minus 0.25 into 0.2 is how much? It is 25 into 2 is 50, and then you have 3 decimal points, so it will become 1, 2, 3, so it is 0.05, right? Minus 0.05, right? Minus 0.05. If you have finding it difficult, you can do this calculation in the calculator. Okay. So and I found the second term. Now the third term, it is let me see, minus 0.25, right? Minus 0.25 into, and this is minus 0.5 into 9 is minus 4.5, right? Minus 4.5 minus 0. Okay, so that's okay. There you go. This is the numerator, divided by the denominator. I need to find the denominator separately because I can use that same value for the rest of the answer, right? So the denominator over here is, here it is 1 into, let me see, 0.71 into 0.5. 0.71 into 0.5 to 0.5, and this is minus and minus becomes plus, so it is minus. This is 0.2, 0.2, 0.04, right? Minus 0.04, okay, and this becomes plus 0.5, plus 0.5 into, let me see, 0.5 into, what is this? This is minus 0.25, minus 0.25, minus 0.25, and this is minus and minus becomes plus, so it is minus 0.05, right? Minus 0.05, okay, and then it will become, so that is the second term. Now third term is minus 0.25, right? So minus 0.25 into minus 0.25 into, this is 0.5 into 0.2 is nothing but two decimal place, right? So it is 0.1. So this is 0.1, 0.1, and this will become 0.1 plus 0 minus becomes plus, right? So it's plus 0.25 into 0.71 plus 0.25 into 0.71. Close the bracket and close the bracket again. So this is the numerator term. So find the value. So I will find the value right now. So let me see here. I think I will just reduce and make it more simple. What's 1.8 plus, let me see, what is this? This is nothing but 6 into bracket minus 0.25 minus 0.05. 6 into minus 0.25 minus 0.05, and you will get minus 9 by 5, which is minus 1.8. Wow, so this is minus 1.8, minus 1.8, and so this is the only thing left behind, right? So what is this? This is 0.25 into 4.5, which is 1.125 plus, so this is plus 1.125, the whole divided by, now look at the denominator. Denominator also I'll find separately, right? That's much easier, so you won't make mistake. 0.71 into 0.5. I'll find this. This 0.71 into 0.5, 0.5 minus 0.04, minus 0.04, okay, minus 0.0. You don't need bracket, right, for this. It's okay, minus 0.04. So you will get 0.315. So the first term is 0.315. Now what about the second term? Second term is 0.5 into bracket minus 0.25 minus 0.05, and you will get is minus 3 by this minus 0.15, minus 0.15, minus 0.15. Now that the last term you have is minus, let me see, minus 0.25 minus 0.25 into bracket 0.1 plus, right? 0.1 plus, this is 0.25 into 0.71, 0.25 into 0.71, 0.71. That's it, right? Close the bracket again, right? So you will get minus 0. Let me see, minus 0.06935. Okay, so here now 1.8 and 1.8 and minus 1.8 will cancel each other. You will have 1.125 divided by, and the denominator will be, let me see, this is the answer, right? So I don't have to find that again. This is the answer. So answer plus 0.315 minus 0.15, and you will get is 0.095 5625. This is the denominator. So now I can use a denominator for other terms also, right? That's why. So let me see if I find the value of V2. V2 is 1.125 divided by 0.095625, and you will get the answer as 7.765. So it will become 11.765 volt. This is the value of V2. Next I'm going to find the value of V3. So I'm going to find the value of V3. So V3, in the V3 the last column will be different, the remaining are the same, right? It means it is 1 minus 0.5 minus 0.25. 1 minus 0.5 minus 0.25. The second column also will be the same, minus 0.5 minus 0.5, 0.71, and the other term will be minus 0.2. Minus 0.2. Okay, and the third column will be this one, minus 609. Minus 609. Okay, divided by, and the denominator will be the same, that is 1 minus 0.5 minus 0.25 minus 0.5, 0.71 minus 0.2 minus 609. Okay, no, that's not minus 609, this one, right? Minus 0.25 minus 0.25 minus 0.2 minus 0.2 and 0.5. Here the denominator will be the same, right? So it doesn't matter anyway you have to write correctly. Okay, so now let's do this calculation. So here it will become 1 into 0.71 into 9, 0.71 into 9 minus 0, so that's okay, that is done. Next is minus of minus becomes plus, so it is plus 0.5 into 0.5 into, this is nothing but minus 4.5, right? Minus 4.5 and this is 0, right? Into 0, so that's that. Minus 6 into this is nothing but 0.1, right? This is 0.1, so 0.1, right? 0.1, and this is plus 0.71 into 0.25, close the bracket. Okay, this is the numerator, and the denominator will be the same, that is 0.095 625. So you need to find only the numerator, or you can find, if you want, you can find the direct answer itself. Okay, I'll try to find the direct answer now itself. So which means that the first it will be, let me see if I can do it like that, 0.71 into 9, right? 0.71 into 9 is how much? This is it is 6.39. So it is 6.39. Okay, it will be, this is minus, this is 4.5 into 0.5. 4.5 into 0.5 is, it is 2.25. So this is minus 2.25, and this is again, this is minus, and what about this? This is 6 into, right? 6 into bracket 0.1 plus 0.71 into 0.25. 0.71 into 0.25, and then you will get is minus 1.665 by 0.09565. So which means the answer is 6.39 minus 2.25 minus 1.665, and you will get is 99 by 40. Now this is the numerator, right? I need to find all the answer. So it will be bracket, I'll put 6.39 minus 2.25 minus 1.665, right? Divide by 0.095625, right? So you will get is 25.882 volt. So which is 25.8823. So it's 82 volt. This is the answer of V3, right? So which means V3 is greater, right? V3 is greater. Here V2 is only this much, but V3 is 25 points. So V3 is greater, which means the voltage, which means the current across the 5 ohm resistor is flowing from V3 to V2, because current always flows from a higher potential to a lower potential. So here V3 is greater, V2 is lesser, which means the current is flowing from V3 to V2. Okay, but here the question is find the voltage across 5 ohm. Voltage is nothing but V3 minus V2. So therefore voltage across the 5 ohm resistor is voltage across the 5 ohm resistor is equal to V3 minus V2, which is equal to 25.882 minus 11.765 minus 11.765, which is equal to, let me see, 25.882 minus 11.765, and you will get the answer as 14.117. So answer is 14.117 volt. This is the answer. Okay.